And we're set up on a very secure surface. We're going to treat this countertop like it would be if it was concrete. All right. So concrete's rated for roughly 1,000 PSI. All right. So we know with this setup, with our outrigger pads down, that we're not going to exceed that PSI load. But that's something we always have to consider whenever we set our cranes up. We have to set up how much weight we're going to be translating to that soil underneath that outrigger pad. And really understanding that when we do the math on it, making sure the math comes up to a square inch pressure rating that soil can obtain. So for instance, your organic soils, your front yards, your lawns, those are good for about 23 PSI. All right. So when you put your dunnage down, if you're going to exceed 23 pounds per square inch of displacement, you need to increase the amount of dunnage you're putting down and create a larger footprint for your outrigger pad. We're seeing a lot of cranes go over because of this reason, because we're failing the soil, and we're ending up having problems with that, knowing the soil displacement issues. All right. So that's the first thing. Next, we have to look at the kind of crane we're using. We're using a Lee Beer style crane here. This is a boom truck crane. All right, we do have an offset jib on it. I don't have a load chart for this crane, but we know with most boom truck cranes, we are strongest, not over our side actually, but if we rotate all the way around here, coming around to the rear is where we're strongest. Our strongest leverage point is off the rear of this truck because now we have the entire chassis as well as the engine and transmission as a counterweight. All right. So that's usually, generally speaking, on boom truck style cranes, your strongest pick point is going to be off the rear. In the event that you go, let me get underneath our electrical hazard here, the light bulb. If you end up going off over one outrigger, this is called point loading. So in the event that we are picking up my cup here with our crane, I'd be putting all of my pressure on this single outrigger. All right. And that's when we figure out that outrigger displacement. We need to be figuring out for that exact outrigger. So the way in which we do this is we take the weight of our crane, all right, divided by our 4 outriggers, add in the weight of a maximum pick, because that maximum pick is going to be on one outrigger, all right, and then divide that by the number of square inches we have in that outrigger displacement. And that's how we come up with how many pounds per square inch of this load we'll be translating to this outrigger pad. And that's how we're able to figure that out. That's just a basic introduction on how we're going to figure those things out and how we're going to go about setting our crane up. When we set our crane up, though, we really want to make sure we are within 1 degree of level. And that 1 degree of level, if I'm going to spin my crane around here for a second, and I'm going to drop the boom down as though we were cradling this crane for the day. So it's the end of the day or the beginning of the day even. We're going to cradle this crane. Give me a second. My hydraulics are a little slow. So we've cradled the crane. All right, this is how it shows up on the job site. Imagine that the boom is fully retracted and there is no offset jib on it. We want to find our level point at the top of the upper carrier. The upper carrier is that part of the boom that's sitting in rest. This is really where you want to be placing your 4-foot level to find that true degree of level. Though we want to use the levels on the truck and we want to use our 4-foot level forward and backwards on the chassis to find level, the last place you really want to check is up top on that upper carrier. And that upper carrier, you're looking at no greater than 1 degree out of level. And the way you know that on most levels, there's 2 lines. And your bubble sits in the middle of the 2 lines. If that bubble is touching one of the lines, that's within 1 degree of level. If your bubble is outside that line or covering part of that line, you're outside of 1 degree of bubble or of level with the bubble. Wow, it's a lot of bubbles and levels there. So that's kind of how we just look at setup. All right, let's come out of cradle here and come on up. Yeah, so I hear in my ear that somebody would like to know the formula for figuring out that displacement again. The formula is you take the weight of the truck, the chassis of the truck, divided by the number of outriggers you have, add in the weight of the maximum load you are going to pick for that day, whatever the maximum load is, and then divide that by the number of square inches of dunnage you have down for displacement. So you obviously have to convert, if you have a 4 foot by 4 foot, you need to convert that to inches and multiply 48 by 48, and that tells you how many square inches you have. And then you divide the maximum weight on that one outrigger by the number of square inches, and that's how you come up with the displacement. Does that answer the question? Awesome. Wonderful. All right. So that kind of gets us an idea of how we get our crane set up. The other thing we're going to talk about when we have our crane set up is our electrical hazards here. So it's kind of hard to see in the video, but if we have a pendant light hanging down right here, we're going to treat that as our electrical hazard. All right. Per the Z133, which is the safety standard for our industry, it says that a crane can never operate closer than 10 feet to an unprotected energized line. So no matter what line it is, 10 foot is our rule. Though OSHA has different regulations for construction industry, the Z133 allows us to be 10 foot. All right. So this is very key to knowing what industry you're working for. If you're doing lifts for AC units on top of a building, you are governed by the OSHA standards of crane work, cranes and derricks. That is a 50-foot guideline from all energized wires, 50 kV and under. If you're doing tree work, though, with your crane, you fall under Z133, and it is 10 foot from all unguarded energized conductors. So it's a little bit of a gray area there, but hopefully that helps out understand that a little bit better. Before I move on, do we have any questions, Kale? All right. If you have any questions at any point, I do have my phone up watching myself give this out so I can see the live comments, as well as Kale is on the computer and he can see the live comments as well. So stop at any time. Let me know. I know we have 2 hours slated for this great takedown today. We're going to hit huge production numbers with this takedown. But if you have questions, let me know. We'll get stopped. So now we've got our crane set up. We have our offset jib on, and we're going to swing our crane on over. All right. Our first pick of the day, we're going to actually pick the very top of this piece out. All right. We have a 4-legged bridle on here, 4-legged spider sling. And a 4-legged spider sling is very unique. I'm going to cable up here for a second. All right. So we have 4 independent slings with 1 attachment point. And that's called a bridle. And that's a 4-legged bridle. What's unique about a 4-legged bridle is it falls under the geometric principle of triangles. And at no point is a 4-legged bridle any stronger than a 3-legged bridle. So if we have 3 legs tied off, and I'm just going to tie these off real quick so we can kind of talk about it. When we have 3 legs tied off, if we add in a 4th leg, we are actually gaining no capacity any more than what we had with 3 legs. Reason being is, at any given point in time, only 3 legs are fully sharing the load. The 4th leg is actually is a stabilizer because the triangle principle of geometry will not allow it to work. A triangle is our strongest point. So even if we had all 4 of these legs attached, 3 legs are getting all of the weight, and 1 leg is just acting as stabilization at all points. All right. So therefore, if you ever see a question like on a quiz, maybe at the end of this webinar about a 4-legged bridle versus a 3-legged bridle, a 4-legged bridle gains you no more strength. You gain stability, but you do not gain any more capacity. So we're going to adjust our slings, get our slings all nice and tight. All right. What I've chosen to go with here is 2 spider legs up top, and then what I call 2 balancing legs down on the lower branch structure. All right. So we have all 4 legs attached, all right, to our upper suspension. And then we're going to talk about how do we pre-tension. So we want to make sure our crane is in plumb. The way we do that is make sure the crane hook is directly over our load. All right. And generally speaking, before the climber makes their cut, they ask the crane operator to put tension on. That's called pre-tensioning. A lot of new operators make the mistake of pre-tensioning purely with the load line. And when you pre-tension with a load line, you actually create what's called boom deflection. The crane bends. Well, as that crane bends and we cut this load free, this load now is going to drift further away from the crane because I've created tension downward. And now you can see the ball is actually further away from the load than where it was when we're not under tension. So if that load were to drift away and outside the capacity of the crane, we could flip the crane. So a much better way to go ahead and pull pre-tension is actually to boom up and create pre-tension with the boom by going backwards. This offsets the tip of the boom just a little bit further back towards the crane. It pulls tension, and when the piece is cut, it should stay right still. Let me fire up my chainsaw here. Kale, can you give me some chainsaw noise there? There it is. There's the chainsaw noise. Obviously, with my handsaw here today, this is going to be our chainsaw. Clearly, I'm not wearing any PPE, Jason. Thank you for the comment. I did see it. No, I'm not wearing PPE because I'm taking down a tree inside my house with my model crane. You're watching me play with my toys today. This is what I do pretty much every night, just play with toys. So no, I'm not wearing any PPE. Obviously, we're running a chainsaw. We want to wear full PPE, eyes, ears, helmet, as well as chainsaw protection if you're operating on the ground. So I don't have that, but we're going to go ahead and continue on anyway. All right, for this first pick, what I'm going to do is I'm going to do is a V cut, all right? With a V cut, I'm going to cut down partially on one way and then come in the opposing angle and cut the other direction. All right. And there we go. So that piece got cut free, and you saw what happened. As soon as it was cut free, it lifted. All right. And it lifted and drifted back towards our crane, which is what we want. We always want to be moving pieces back towards the crane versus further away. We gain capacity the closer to the crane we get. We lose capacity the further from the crane we get. So that's why when we pre-tension with a boom, we move this piece towards the crane. So when a piece is cut free, it does exactly that. It lifts and comes towards the crane. All right, at this point, we're going to go ahead and swing our load over to our landing zone here. All right, making sure nobody's underneath our load because we don't ever want to be operating with people underneath the load. I'm going to clear our electrical hazard. At this point right here, I'm getting to the point where I'm putting a lot of pressure on one outrigger. This is where we talked about that displacement, how much weight this outrigger is seeing. All right, the opposite outrigger on the front driver's side of the truck is actually starting to lift off the pad a little bit. Because even with this small load we have, we are still getting that tipping axis. All right. If we continue to go down, that tipping axis is going to get more and more pronounced. All right. The further back to the rear we swing, though, we're back in that strongest point possible. All right. So we want to be operating towards the rear. We're going to boom up a little bit here. And we're going to cable down. All right. As we cable down, we really want to make sure our ground crew does not actually touch our load until it's at chest level before they start manipulating. So once it's at chest level, we can go ahead and grab it and lay it on down. Down it comes. My ground workers come over here, run over here real quick, and take our slings off. All right, we'll come for the next pick. So that's our first pick. I think we did pretty well, actually. I'm somewhat surprised it went as well as it did, to be quite honest with you. All right, what's everybody think so far? What do we feel about this? What questions do we have? Or wonderful.
Oh, here we go. My first question is about how do you find the PSI, or I guess the displacement, on a knuckle boom crane? Is it any different than the
good question
you're using?
So when looking at knuckle boom cranes, we have to understand the first principle of knuckle boom cranes is different in the outriggers. Knuckle boom cranes don't have outriggers; they have stabilizers. What creates the strength in a knuckle boom crane is the flex of the chassis and suspension in contact with ground. So whereas a boom truck crane, we want to take all of the flex out of the suspension and make it as stiff as possible. Sorry, on a load line crane, make it as stiff as possible to translate all that weight through the outriggers to the soil below. On a knuckle boom crane, we actually want to leave the tires in contact. We want to leave the suspension compressed. So therefore, the entire chassis and frame can flex through the suspension onto the tires. The stabilizers are just doing that. They're stabilizing chassis flip. So it's really hard to actually come up with the amount of displacement you're going to have because you're still going to have displacement on all points of contact. So really the best way to do it, if you're truly going to find it out, is to take the weight of the crane, divided by all points of contact, which includes your tires, your stabilizers, and such. Add the maximum amount of load, all right? And then divide by your square inches. You're going to get the closest you can. And even then, you're still not going to be quite accurate because it's two different principles of cranes, all right? Hopefully that answered your question a little bit.
I think that's a great answer. Jay Squires is asking, what if we don't have access to the spider legs and only have straps?
So if you have straps similar to the strap I have here, this is a whoopee strap, but we'll pretend it's an endless loop. You could use multiple endless loops and do the same thing. And for this next pick, we can talk about using a single sling or multiples. But if I had multiples of this spider leg type or this whoopee type strap, I could very easily use a shackle or a soft shackle, all right, and put it on that way. The big thing we don't want to do, which our crane does not have, is once we've put our slings on the crane hook, we want to leave them there. We don't want to be taking slings on and off the hook all day. So once we've loaded the slings that we're going to put on for the day, so if we wanted to run our spider legs in one endless loop sling, we want to pin this gate shut. Reason being is in the event as you're transversing through the tree, all right, so let's just drop this down here for a second. All right, so say we're pulling slings through the tree, right? As we know sometimes happens, slings get wrapped over a branch. And in the event that this sling comes up and over the gate and loads the gate, you get what's called dynamic rollout. All right. If I grab my carabiner here off the wall, I can kind of show you that. So dynamic rollout is when you take a sling, make this a little bit longer here. All right. Hopefully everybody can see this all right. So say this is our crane sling, or our sling, crane sling and crane hook. If this sling comes up and over the gate, it's going to be kind of hard to do on this one, and pushes downward, you can drop the sling out. So what we really want to focus on is making sure that we don't have a chance where this sling is going to come up over this gate and fail the gate open, and then your slings drop. So be careful. I know there's a lot of people who have common practice of using an endless round sling, going around the piece, threading it onto the piece, and then putting it right onto the crane ball. The more times you open and close that gate, the more chance you have for a gate failure and having that dynamic rollout situation. So it's best to use a shackle or a soft shackle or spider leg type slings to do your attachments. There's nothing wrong with using endless rounds, but again, just be careful of that problem there. All right. What else do we have? All right. So the next pick we're going to look at is we got this weird stem at the top here. It's got these two pieces coming off it, and we got some lower pieces, and we're actually going to cut a little bit of trunk section out now. It's a little bit heavier pick. We're going to get some of this trunk section taken out. So to do that, what we're going to do is we're actually going to attach one sling as a stabilizer down here on a branch attachment. We're going to slide this closer to the trunk. All right. We're going to use an opposing sling on this other branch attachment and do the same thing and slide that down to the base as well. All right. So what we've done here is we've captured on two sides, and hopefully that'll give us enough. But what we don't want to have is we don't want to have the piece flip over on us. So if we're too low attached, we could flip over. So the way we solve that is by putting some half hitches, followed by, and we can use clove hitches here, you can use running bowlines, lots of different forms of attachment here. But we want to go ahead and create a little bit more attachment further up. So in the event this piece wants to roll, we're stabilizing that roll up top. So we don't roll the whole piece over and end up impacting where our climber's at. All right. So now we go ahead and I will do that. All right, so now I'm just kind of equalizing all my legs out. So what I've done is I've attached two slings to what I would call big branch structure. So that's going to carry the majority of our weight. I have got two other slings further up that have been half hitched further out on the branch, and then full closed clove hitch further down, which is going to be your stronger point. And then we're going to cut down here and get this piece lifted out. If we had only selected our two here, we had the potential for the piece to want to rotate and flip. So this is hopefully going to prevent that rotating and flipping from happening. All right. All right, and what cut I'm using here is I'm using a straight through cut. All right. Crane looks good. We're pre-tensioned. Everything looks good, and we're going to continue on. You know, before you ever finish your cut as a climber, you always want to make sure everything looks good. All right, there we go. So that piece swung to me because of the saw blade, not because of the crane. But again, we've picked the piece up. The piece has slid back towards the crane, and it's stabilized. We don't have any rotation occurring. If we had just had on the lower pieces here, and we take these off, let's watch what happens. All right. So if we didn't have the upper attachments, you can see this piece has potential to want to roll out and flip. We had a climber there and it rolled and flipped, we could easily have crushed our climber. So that's why we use the attachment on these upper legs to help prevent that. All right. Again, we had attachment points, and I'll bring this a little bit closer to the camera here in a second so we can see it a little bit better. Once I get it reset, hold on. Sorry. So much easier in real life. All right. Let me bring it over here to the camera, and you guys take a better look at this. All right. So what we had So we had 2 slings. All right, we had half hitched off this side, and then we had cloved the bottom half. Oh, come here. Screw. Around. All right. So by having it tied off as such, it prevented our piece from wanting to flip back in either way. This is how you can get a low point attachment on strong wood for a heavier pick, and then stabilize by doing half hitches further out the branches, and then doing cloves or running bolins or timber hitch or cow hitch further down. Again, if we take out this upper attachment points, we can see if we had just attached the lower side, what would have occurred. And it would flip. All right. I'm not going to take that one off the ground because I got an amazing ground guy that can pick it off in midair. It's good like that. All right. And we're going to come back over here. Any questions on that? On that attachment or that pick?
I have a question. Why are you using... You've used 2 different kinds of cuts so far. What is the difference? When do you use these cuts?
So the question we had was the different cuts we've used, all right, and why do we use the cuts we use? A lot of times your cuts are going to be very dependent on the situation that as a climber you need to put yourself in. So a V cut I want to use a lot of times to trap the piece from moving, to allow the climber a place to egress down. So if I make my V cut, I can store my saw before my operator makes any movements, and I can climb out of the way and be out of the way so I'm not looking at the pick. And also it prevents the butt from wanting to slide at the climber. So if I'm setting up on this side of this tree and I'm making my V cuts like this, this traps the piece from coming at me. So if I was in the middle and making my V cuts this way, though, the piece can slide back and forth. So we use it as a protection with the V cut. The V cut's very successful in protecting things and keeping things from rotating and moving until you're ready for them to. The straight through cut works really well on big wood, on flat pieces that you want to pick straight up when you have multiple points of attachment. We really want to stay away from using things such as a snap cut or dynamic loading cuts. It's like the Humboldt notch or a conventional notch.
I have another one here.
So hopefully we're going to talk about some lifting cuts here in a minute where we actually pick pieces up and whatnot.
Okay.
Right. So
Athena
if we were just use one sling attachment, and we were just tie one sling off to a piece, to a sub piece, we have to worry about which way it's going to swing when we cut it. So we're going to put just a single sling attachment on this. And we're going to cut this piece free. We're going to, again, pull the same way we go back the other way here, sorry. I'm not used to running a crane that has hand control like this. All right. We're going to cut this one piece free. When we cut this one piece free, even though we have a separate branch on the other side as a balance point, watch what happens. And get over here. I can see where I can cut without cutting all my other slings. All right. So we cut the piece free, and as we pick it up, watch the way the piece hangs. So even with branch attachments on the opposite side, bring this over here a little bit so people can see a little better. All right. Even with those branch attachments hanging on the opposite side, our piece is still going to hang oriented the same direction as our sling attachment is. So anytime you have a single sling attachment, your piece that was flat like this is always going to sling and swing to the butt side that the sling attachment's on. So very careful, climbers, if you're making your cut and your sling attachment's directly above you, meaning where it's attached comes around the branch and then exits towards the crane ball, you don't want to end your cut opposite of that. You want to start your cut opposite of that and cut towards you. Because as you cut, that piece is going to pick up, it's going to pinch your saw if you started your cut on your side and cut through to the other side. So always making sure when we cut this piece flat like this, all right, if my climber is sitting here directly underneath this branch, we want to start our cut over here and finish on the same side as our attachment point. Because as we cut, this piece is going to want to compress. It's going to compress on this side and lift on this side. If we had started the cut on this side, though, and pushed all the way through, we end up with that compression on this side. We end up with a pinch bar, and then we have telling our operator, swing it left, swing it right, do this, do that, to try to get your saw unpinched, when simply just changing where you started your cut will make the difference on that. Bring this piece on down. Work around this electrical hazard really is difficult. All right. So we're making progress on our tree. We're three cuts down, and we've only spent 20 minutes. Really good return on hours on this one. All right. So the question was, could I explain the difference between a bypass cut and a snap cut? I can try to explain the difference. A bypass cut is when your two notches your cuts overlap each other. So there's free wood, and you've actually just bypassed through your cut. So on a V cut, if you were to cut down on one side and cut through on this side and actually through your cut, that's a bypass cut. A snap cut is where you leave wood between the two. So where you've cut one piece and another, and there's actually wood between the two, and you have to snap the grain off in order for it to free. That's the difference between a bypass. A bypass, your cuts actually do intersect and connect, where a snap cut, they do not.
I have another one here. Athena Odell wants to know why you're attaching on all the branches as compared to the trunk itself, which I know you went over a little bit, but at what point do you start attaching to the trunk as opposed to just the limbs?
So it's a great question. Is when do I start attaching my slings to trunk material and not branch material? Once I get to the point where either A, the limb attachment is not going to be sufficient to hold the weight of the trunk material, or B, I'm in a situation where I'm worried about roll and a piece moving. But generally speaking, I always try to go with a branch union where it meets the trunk, because that's usually going to be our strongest point on most trees. Now, obviously, you have to look at the branch union, look for included bark, look for cavities, unique growth patterns, and those kind of things. But on a good, healthy growth union, it's going to be a very strong attachment point. It's also its natural weighted center. So if I have branch growing out this way, this branch can only get so long and not overcome this union here in the event that it would snap it. So therefore, I know my balance point is generally pretty good closer to the trunk, because I'm not having all this branch material out here. Otherwise, it wouldn't exist because it'd snap the trunk off. So it's a little bit of experience. And then once I get down to trunk material and I don't have any branch unions left, obviously then we're attaching just a trunk. And sometimes it just comes to personal preference, and I just enjoy attaching to branches over trunk or vice versa. We are going to look at doing the secret handshake here in a little while, and how the secret handshake can be utilized on trunk sections to prevent pieces from sliding one way or the other. All right. This next piece we're going to do is this limb here, this lateral coming out towards the camera. All right. To do this one, though, we're going to do two different slings tied at two different locations to do a spider leg in order to balance this piece to pick it out. So the good news about spider legs is we can tie them at different increments to have a little bit more balance. So the first one we can tie up here. All right. Let me get my slings out of the way. There we go. And I'm just using a clove hitch because it's very easy to tie with throw line on such a small tree. Again, you can use running bowline, you can use timber hitch, cow hitch, or you can use closed clove hitches. Just make sure you back them up on most large branch structure. This sling down here, I'm going to extend a little bit further towards the base union where it meets the tree and attach that. All right. So I have two different slings attached at two different lengths. This is where spider legs really come in handy over using your typical endless rounds, because you're limited on your attachments. All right, we're going to just boom up just a little bit here to get our pre-tension. All right, and then we can just cut this piece straight through. There's no need to notch this piece because we're not picking it up. We want to leave it directly in place. So if you can imagine, there's some type of house structure here, and we don't want this piece to pick up or swing. We just want to leave it right in its orientation. So I usually do a top cut first, and then I come in and finish the bottom cut. like so. All right. As you can see how this piece picked up, it maintained pretty much its natural orientation on the way it was actually attached to the tree before we cut it free. That's a spider leg or a balance pick cut using two different slings. The beauty of the spider leg is you're able to balance pieces that way very easily. So we have the load shared between two different slings, all right? And we've maintained that angle, all right? So now our piece has stayed maintained in this orientation. The big thing here is you want to make sure your slings exit on opposite directions. I didn't do that. I actually opposited them on the same direction. My mistake. And you can see when I cut it free, the piece rotated downward, all right? If I had attached this one real quick, I'm going to untie it and retie it again on the other direction. Oh, come here. Sorry, hold with me. All right. You can see the piece actually, that's got a little too tight, that one. Loosen that up a little bit. All right, so now I have the same angle, but you can see the piece lays flat because my sling is exiting on this side of the branch and then exiting on the other opposite side of the branch. And that prevents the branch from wanting to roll one way or the other. So when you attach your slings, pay attention to how the sling's attached to prevent that kind of roll from occurring. All right. No need to bring this one all the way to the ground. Again, I have my ultra amazing ground guy that's going to pick it up in midair. Yeah, chest height, yeah. So this is the first time I've ever done a crane removal with a crane that I'm bigger than, and I'm bigger than the tree. This is fun. Highly recommend everybody go out and buy themselves a model crane and build yourself a model tree because this is actually a lot of fun. And I feel bad that you guys are just watching. All right, so now we're going to get on this trunk piece here. All right, we got a little bit of trunk section, and we're going to do what's called the secret handshake knot, the secret handshake attachment on this piece here. I'm going to tie it first, and then we're going to discuss it. A little bit more. So the way we tie this is one sling comes around the tree and is a running bowline on the other sling. So it's a running bowline back, or it's a bowline back to itself, which creates the running bowline on the other side. All right, so let me just tie this, and again, I'm gonna get all this tied, and then we'll talk about it. A little easier then. All right, one sling goes there, and the other one comes around and attaches on this side. And again, we're using the same bowline on the leg here. All right. So what we have is kind of hard to see, I'm sure, but I'll do my best here to show you. The other sling's kind of out of the way a little bit. Is we've got two bowlines attached that slide on each other and pull tight. All right. So as we pull up, they pull tight. All right. And again, it's going to be kind of hard to see until we get the piece free, and then I'll show you a little bit more up close. There we go. I got my tension pulled. And again, you can see how the slings, I'm not sure how well you guys can see it or not, but you can see how the slings are actually pulling on opposing directions. All right. And we're splitting the trunk this way. This allows us to pull straight vertically versus having any slide left or right. And again, I would straight cut through. There's no need to notch this or create a snap cut or a bypass cut or a V or anything like that, and just straight cut right through. All right. Now, obviously our piece has got this nice long branch attachment on it. We could have solved that by putting a simple strap on this side just to prevent that movement. We didn't do that, so no sense in doing it now, I guess, but why not, right? How great would it be if you could just stop and say, you know what, let's put another sling on that. Yeah, sure. All right. Let me bring this over to the camera and showcase this a little bit better. Yeah, I bumped the crane off the table, so I'll have to reset that. Give me a second. All right. Get our crane back up on its outrigger so I knocked them off. All right, so you can see here how we have this attachment. Okay. I'm going to take this one off because we didn't really have that on there at the beginning. All right. So this works by pulling in opposite directions on two different bowlines. So we'll have a bowline from this sling that goes around the middle here, and a bowline from the other sling that goes around this side. And that's what creates our secret handshake. All right. And even with this long limb attached here, we stay pretty balanced. All right. And it allows us to pick perfectly vertical straight up. And I agree, Adam. It is a shame that treestuff.com would not have given me a hydraulic 1/5 scale crane. That'd have been awesome. But they provided me this crane, and I'm very happy about it. So I can't say anything too bad. All right. So again, you can see how our secret handshake, both pieces are sliding on the opposite piece. All right. It goes right through the middle. All right. Any questions about the secret handshake before we keep moving? All right. How many viewers are we up to? Just curious. 99. Let's get one more, get 100. Why not? Everybody's inside, can't go anywhere because of coronavirus anyway. All right. Oh, sad. Hey, well, congratulations, Mr. 100, whoever you were. Congratulations. You're the 100th person. All right. So now we've got these two large, long branches on opposite ends of our trunk section, and we want to remove them with the trunk attached. So we have multiple options here. We could do a trunk attachment, but then we're going to have to worry about balancing. The easier attachment here would be attach one sling out here as such, and another sling on the opposite side. The problem is if we do it like so, we exceed our maximum angle for our slings. We never really want to exceed more than 120-degree sling angle, because at over 120 degrees, we're actually pulling more weight this way than we are this way. And what could happen is we could either end up with a failure here by collapsing these unions upward, or actually breaking the branch material off and collapsing it that way. So we really want to be careful on how we do that. There's some ways to overcome that. One of the ways you can overcome that is by using the half hitch again. So bring your slings down a little bit. All right. What you're going to do is you're going to half hitch interior and then run your hitch out and tie on the outside here. All right. And do the same thing on this side. All right. We just do a half hitch here and run this further out and do our another attachment out here. Okay. So we've transferred the load. We've gotten our slings closer together. Anytime we can get our slings closer together, we're helping out that angle, which is good for what we want. Okay. Slide this over just a wee little bit. All right. And now we're being able to pull in a much better sling angle. And we still have dispersed that weight further out. All right. The other option, obviously, would be attach straight inward here at the union. But then you may have to worry about some balancing of the angles on really long branches. This helps trying to control those long branches. All right. Let's go ahead and see if we can make a cut here. All right. You can see our piece is cut free here. So once it's cut free and we cable up, the piece stays in pretty much that same orientation we had it in. I'm going to bring this a little bit closer to the camera so you can see how we had this tied here. So what we've done is by reducing that sling angle, we're bringing it closer attachment, comes down to our first attachment point and then slides further out to our primary or secondary attachment point. And that's just dispersing our load. So all of our load is not being shared on one point. We've dispersed that load out across the branch structure a little better. This works really well on large branches. I wouldn't do this on very small structure branches. You worry about collapsing and failing them. But on large diameter leaders, on your larger oaks, your maples, cottonwoods, those bigger structure trees that have really big unions in them, this is a really good way to accomplish that. Nope. The question was there a name for that? I don't know of one. If somebody has a name for it, I'd love to hear it. I'm sure I'm not the inventor of it by any means.
Well, it sounds like
I
you
will
get
not
to come
claim
up
to
with
be.
a name.
I'd rather not. I'm sure Mark Chisholm has come up with a really cool name for it, like he did with the X cut and the V cuts and all that. It's where I learned most of my crane knowledge from is Mark Chisholm, so I am sure he's come up with some name for it. All right, this next pick we're going to do is a single leg pick. And we're actually going to try to do a lifting pick. And we're going to try to lift this back, this branch here, sorry, this forward branch here, so you guys can see it. We're going to try to lift it and stand it straight upright. This is going to be a little bit of a challenge to do by myself because I'm going to have to be cutter and crane operator all in one, but we'll see what we can make happen. All right. In order to do this, though, what we're going to do is we're actually going to take our jib off now because we're getting to the point where we need to be closer to this crane. So I'm going to drop it down and take the jib off real quick. If it was only this easy in real life. All right. And the jib is stowed. Fastest jib ever. All right. Cable up. And we're going to go after this piece here. So again, we're going to use a single leg attachment. So just one sling. So a nice single attachment here. If you want to put a secondary attachment on just to prevent rolling, you could do a second sling in the opposite direction. But for this demonstration, we're going to leave it just the way it is. Okay. Now, in order to do a lift cut here, we're going to have to place a notch on the top side and then flat cut the bottom side to create a shelf for the piece to sit on as we lift it up. So bear with me as we give this a shot. All right, so I've got the notch cut. I might have almost knocked the crane over there. Glad cranes don't move like this in real life. They really suck. All right, hold on. Okay, our crane's back set up again. Sorry about that, folks. So now that I've got my top notch cut, what I'm going to do is I'm going to start cutting my bottom notch. And my bottom cut, we want to keep parallel surface towards the ground level so this branch can actually sit on and not drop down. So we're just going to do a nice flat cut here. All right. So now I've got it cut. What we're going to do is we're going to try to cable up. And as our operator cables up, they're actually going to swing the piece in line with the tree until it's sitting perfectly upright. So you can see now how it's sitting perfectly upright. We can cut this piece free. So we can finish our cut and cut our piece free. All right. Our piece would be sitting right here on this piece here. Our crane lifts it up, and we're out of the way. All right. So that's how we can take a piece that's sitting down perpendicular or parallel to the land or the earth, pick it upright to be perpendicular, and do a lifting cut. Again, it's a top notch with a bottom flat cut. All right, we got some more trunk wood it looks like to take off here. Now we're starting to get a little bit bigger pieces. We're going to start looking at taking bigger pieces off. All right. Cable up just a little bit. There we go. So our first attachment point, we're going to come to this limb here, attaching close to the limb. Second attachment point is going to be a little bit further out on this limb. All right, this first union. Because this branch is bigger than this branch, we have to offset that for the distance there. Everybody also wave at Taylor Hamill, who's watching, who's doing a webinar next week. Hey, Taylor, how you doing? Glad to see you're joining us. Can't wait to see your webinar next week, buddy. And then we're going to do a third attachment on this back leg just as a balancer. This isn't really going to have a lot of tension on it. We just want to be balancing this pick as best as possible. So now we have our 3 legs of our bridle. Remember, this 4th leg doesn't add any capacity to us. All right? It's just going to, we're not even going to use it this time because there's nothing for it to attach to. So we're just going to kind of get it up and out of the way. All right. Now we can go ahead and make our cut on a little bit bigger piece here. All right. So I can see once a piece is cut, the piece stays right where it's at. It's balanced. Our operator then, once our climber is out of the way and clear and free, can give the signal to go ahead and again lift this piece up. Staying nice and clean and slow and steady. Now, we know that anytime that our climber or our operator of our crane cannot see our climber or cannot see their load, they have to have wireless communication. It has to be wireless, hands-free communication. That's in the Z133 2017 standard. All right. So things such as Senas, Tough Talks, and a few of the other radio communication systems out there. I don't know all of them. Not pushing one or the other, but make sure you have some way to communicate with your operator, because the last thing you want to be doing is trying to make a cut and give hand signal at the same time, because we know hand signal up for boom, for hoist up, hoist down, boom up, boom down is awfully hard to get if both hands are on the saw. So make sure you have that communication system already set up ahead of time. And preferably it's that wireless, Bluetooth style communication systems. All right, we lower this to the ground. Now, who's going to clean this mess up? I need a ground crew here. Kale, come clean my mess up.
Isn't that what the dog is for?
Solo is definitely not cleaning any messes up, I can promise you. All right, what other questions we have? Let me take a look here.
We have John
Do we have any other questions at the time?
Oh, sorry.
All right, go ahead.
Sorry, John Stedman was talking about using a Humboldt if utilizing the secret handshake on clean poles to avoid slippage. I wonder if you could explain that a little bit.
So what he's referring to there is using a Humboldt notch on the side to prevent the slings from sliding up the pole. That's really, it is very helpful. Who was the one who said that?
John Stedman.
John, that's a really great point. I'm glad you brought that up. On certain type trees such as beech and other slippery bark type trees, beech is the one that comes to mind off the top of my head right now, where you have to worry about that sling sliding up a spar pole, it's usually really good to go ahead and put a Humboldt on there, a very shallow Humboldt on both sides to capture it. Just making sure where your angle is on your Humboldt is really where you want your attachment for your slings coming out. So your knot would be sitting in the Humboldt actually and exiting on the other side of the Humboldt. What you don't want to have happen is there are a lot of running rope around that edge, and as the operator pulls tight, that running rope is running over that edge. But it's a great point, something you can utilize a lot of times to make things very easy on very slippery wood on spar poles. All right. Also see, all right. On the lift cut, yep.
Yes, yeah, that was what I was going to talk about.
Yep. So on a lifting cut, you really want to orient your notch so it's not going to create a pinch point to your saw and be a wide enough notch on the top where you can achieve the lift. So if you don't need to lift a large distance, don't create a large notch. If you need to overcome a large distance, say on like a flat branch on a live oak where it's laid way out flat and you got to overcome that distance, you're going to need a larger open face notch on top. And then the bottom, we really want to keep that cut flat parallel to the earth. So therefore you create that shelf. If you come in directly below it, what could end up happening as you're lifting up, if it breaks off prematurely, it drops into the cut and dynamically loads your crane. Excuse me, sorry about that. And dynamically loads your crane. So you really want to provide that shelf there, and you can even put your shelf at a little bit of an angle back towards the tree if you needed to, just to provide a good solid structure that's going to allow it to be picked up and lifted straight up. Oh, sorry, battling a little. Yeah, let's take 5 minutes or so on a little intermission here. Let me move some things around, and we'll continue on. Awesome.
We have a bunch of great webinars just like this one scheduled on our Facebook page, so make sure to RSVP to the Facebook event pages for updates. On March 19th at 6 p.m. Eastern Standard Time, rigging expert Taylor Hamill will be talking about advanced arborist rigging theory. So make sure you have your notebook ready because he'll be giving great training on rigging angles, mechanical advantage, and other in-depth topics dealing with multiple rigging scenarios. There will be 2 free CEUs available for anyone who attends this webinar. On April 2nd at 6 p.m. Eastern Standard Time, plant healthcare expert and arboriculture historian Joe Aiken will be giving a webinar on proper fertilizing for creating healthy foliage. There will be 2 free CEUs available for attendees of this webinar. On April 23rd at 6 p.m. Eastern Standard Time, David Anderson of Canopy Watch will be giving a great webinar on canopy exploration techniques and conducting science in the trees. David has some unique experiences in arboriculture, so this is going to be a super interesting webinar. There will be 2 free CEUs available for attendees of this webinar. On May 14th at 6 p.m. Eastern Standard Time, plant healthcare expert Trent Dix will be talking about preparing for the newest invading pest in the U.S., the spotted lanternfly. This webinar will have a lot of important information about battling the spotted lanternfly, so be sure not to miss it. There will be 2 free CEUs available for attendees of this webinar. Keep checking our Facebook events page to stay up to date with all of the great webinars that are on the horizon.
Hi, I'm Cale Royer, head party animal at treestuff.com. I'm here to make sure that everyone knows about our Tree Stuff Party program. Each month, volunteer arborists from different regions host free recreational climbing events powered by treestuff.com, giving local arborists a chance to meet, hang out, climb, and try out some cool new gear in the trees. Every Tree Stuff party is 100% free, so there's no reason to not bring your family, friends, co-workers, and acquaintances. Check our Facebook events page to learn about upcoming Tree Stuff parties, and sign up to be notified when there's a new Tree Stuff party in your neck of the woods at treestuff.com/parties. It's all about seeing friends, making new friends, and having fun in the trees. I hope you can make it to a party soon.
Here are the upcoming Tree Stuff parties in your neck of the woods. On March 14th, Bert Kuhn of Agape Tree Farm is hosting a party in Phillipsburg, New Jersey. This party will be going on between 10 a.m. and 4 p.m. On April 4th, you can join Nick Johnson of Element Arbor in Waynesville, North Carolina, just west of Asheville, for a great Tree Stuff party. Nick's party will be going on between 9 a.m. and 3 p.m. On May 9th, Tree Stuff superfan Jason Dudek will be hosting a party in Mukwonago, Wisconsin, near Milwaukee. Jason's party will go from 10 a.m. to 4 p.m. For more information and addresses, head to our Facebook events page. You can also get more information about these and upcoming Tree Stuff parties by going to treestuff.com/parties.
Well, there's a lot of different things that go into the estimation of a tree.
A wise man once told me never assess a tree from the road. Always walk up on the tree, take a look around 360 around the tree. You never know what the backside of a tree holds. You know, it might be rotten and decayed, and that can totally change how you're going to go about removing that tree and you know, what kind of equipment's going to be needed to do that.
I bit a tree by breaking it down bit by bit to the smallest parts of the job.
We look at it from an hourly standpoint, how the salesmen that we have bid a job on how long they think the job's going to take, and they break it down like that. And then I get a work order that gives me an idea of how much time we're going to be spending on a property.
My customers like it when I can break it down for them and itemize it to show them where their money is going, rather than just saying, oh, I think that tree's about $1,500. Well, why? Well, here's why. My time, my guy's time, my materials that I'm moving out for you, and you have 4 comm drops and a hotline right next to the tree. That's how I reached that conclusion.
Also, a big part of it is obstacles, you know, in the way of hazards. You know, are you removing a monster oak tree, you know, overhanging umpteen million, service drops, primaries, pole-to-pole, houses, garages, you know what I'm saying? You know, those are all big factors. But I think the biggest one is knowing the capabilities of your crew.
Who do you have there? What skill set is there? What is their speed? You know, how well versed are they in being able to develop a complex rigging situation with no guidance?
I usually gauge the neighborhood that I'm bidding in. I gauge how far it is going to be to have the groundsman drag it out. How much equipment am I going to need? Do I need loaders and things like that, or is this something I can do, you know, by hand? How many guys? How long will it take? And of course, then the obvious things, how big is the tree?
It's a large orchestration of many different moving parts.
I always say there are about 300 different variables that go into the estimation of a tree. For me personally, I know the set rate that I want to get per man hour, and then I usually gauge based upon that time it's going to take and everything else I'm going to need, try to come up with a number like that.
Trio caching is a fun tree stuff program based around searching for hidden treasure in the trees. Volunteer arborists from around the world have set caches in their area for climbers to seek out using GPS, their wits, and their climbing skills. To start trio caching, all you have to do is go to treestuff.com/triocache and find a cache near you. We have a few new trio caches to announce. Brandon Othen of Arizona has set trio cache 87 near Phoenix. Sid Howells of Social.
All right, welcome back from our little intermission there. We are halfway through our removal. We're about an hour into our job day. We got our crane. And what we're going to talk about now is we have a pick in this reference that's a little outside of our reach. We actually don't have the reach to reach over here to make that vertical pick that we showed earlier. So we're going to talk about a way we can do actually a sliding pick where it's going to slide this way and we can lift up at the same time. In order to do that, we have to use that same type of notch up top, but we're actually going to angle that notch a little bit. So instead of cutting the notch on the very top of the branch, we're going to cut it at almost between the 9 and 12 o'clock mark on a clock. Okay. And create our other side of the notch here. Okay. Let me clean our notch up just a little bit. It'd be way easier if I had my 536 Li battery-powered saw. All right, there we go. So now we've created that side notch. What we want to do now is we want to do the same type of lifting technique, but we're going to actually put a back cut and flat cut on the same side. We're going to start with our flat cut first, and then we're going to do our back cut. So our flat cut, we want to come in at a little bit of an angle. All right. Let's see here. There we go. Right to the point where we get to the apex of our notch, and that's just creating that flat surface for the lay on. And then we're going to come and do our vertical back cut. And from here, we should be able to begin. I may have to cut a little bit more. Got a little too much holding wood. Hold on. This is that bypass cut we talked about earlier, where we have a little bit of wood left, and we're just going to bypass our 2 cuts. There we go. So now, as we can hoist up, we're going to slide the piece towards the crane and rotate it up. And you can see how it stays attached to the last second and breaks off. And that allows us to get back underneath plumb with the crane. We're not going to be outside the capacity that way, and pick it off in a static fashion. So again, it's a side notch, all right? And then you have a flat bottom cut with a bypass backside cut. That allows us to have a little bit of a lip there and still doing the backside. All right. It can be kind of hard to see, but I'm going to bring this piece over to the camera, and we'll look at it more closely at the camera. All right. So you can see here, all right, this is where we had our notch at. All right. This was that bottom cut was down here, all right, which left our holding wood right in the middle, and this was our back cut. So it's a 3-step cut to do this, and what happens, the branch was sitting like this, it allowed it to roll upright and then get picked off. So that's a sliding cut, all right, with a 3-step back cut, or a 2-step back cut, a bottom cut, and a straight vertical cut. And again, that's a way if you're outside of your reach, you're leaned really far away, you can have the operator bring the piece back plumb with the crane while it's still attached and lift the piece out. Now this next piece here comes right at our crane. All right, so we're going to be very vertical for this piece. You also can see I've switched out our slings to an endless round sling now, instead of the spider legs. Unfortunately, what I have to do now is I have to take the sling off because I don't have a way of using any shackles, and I'm not good enough at splicing to make myself a soft shackle. Not even close to good enough. All right, so there's our attachment point. All right, we've done again attached out here. Now we're very limited on what we can do here because our operator has to be very skilled in bringing the boom down and cable up in order to get this piece to stand upright. But we're going to give it a shot and see how if we can do that. Is that better camera for everybody? All right. So again, we're going to put our top notch on. All right. All right, so there's our top notch. All right. Then we want that flat bottom cut. All right. And now, as an operator, what I'm going to have to do is I'm going to have to boom down and cable up at the same time. And you can see as I can lift the piece up and it stays attached. All right. Now, everything's still attached. Nothing's been broken free. And we've got the piece stood pretty vertical. At this point, the climber can come in and finish the cut. All right. And the piece obviously would move. Piece moves a little bit more dramatically than it would in reality. But you can see there, when I smooth the crane out of the way, you can see where we have our bottom shelf. That shelf is what the piece is resting on as we pick it upright, and that prevents that dynamic loading of the crane. The other thing we can do, and this is getting a little bit more fun, is do a balance pick using a single sling attachment point. This takes a lot of years of experience and a little bit of luck. But with the right amount of luck and a little bit of experience, you actually can judge the balance point on a branch to the point where using a single sling attachment allows you to be able to pick the piece up and leave it in its orientation. So looking at the branch here on the back side, I know it has an upward orientation. I've got 2 branch unions out here, and I've got more wood this way. So I want to cheat my sling out to a little bit past halfway point, hoping that enough weight from the tip overcomes the base. All right. And to do this pick, we're going to do a straight through cut. All right. Let me get everything plumbed up here. All right, we're going to again pull tension by booming up a little bit. All right, we're all nice and plumbed up with our crane. We're just going to cut this straight through. Top cut, and then we're going to finish with a bottom cut. Because if we cut it all the way through, we'll pinch our saw like I just did there. Then we're going to finish with that nice bottom cut. All right, and the piece stays exactly the way it was oriented if you balance it correctly. I got really lucky on this one. All right, so you can see how much distance I had from where the sling attached to the base versus this way, but I had these 2 other branches out here that act as counterbalance. All right, and I'm able to keep that piece nice and balanced as I pick it up and out. Swing it at the camera, make it all dramatic like. All right. Well, we got one more branch to do, and I'd like to hear how the audience would like for me to do this branch. And just send it is not an appropriate response. Jason Dudek. All right.
Nick Orea is saying that your tree is moving so much because there's no leaves on your tree, so you need to put some leaves on your tree.
Yes. Nick, next time I build a tree, you can gladly fly out here from California and help me make miniature leaves and glue them on. The leaves would definitely help dampen the swing and dampen the movement. You're absolutely correct. The other thing that would help is if the wood weighed a little bit more than it did with our crane. Our crane, I think, is rated for lifting this whole thing at this point. So, but no, that's a great point. So Mark says a V-notch. And everybody else says send it. Thank you. Thank you, Nick. Really do love you, buddy.
Wilbur says spider leg if you want.
Okay. All right. So what we'll do is we'll do a V cut and a spider leg. It's a little bit of combination here. Cable up. Put our spider legs back on. All right. So for our spider legs, we're going to have one attached a little bit closer to the tip of our branch. And then another one attached further down at the base down here.
Would you rather do a tip tie and raise with an angled side notch?
Again, Jay, you'd like to see that again? Is that what I'm hearing?
Yeah.
All right. So we're going to do since Mark Gaudette would like the V cut, and somebody else said spiderlings, we're going to do the spider slings and a V cut. We're not really going to be able to do a side notch on this one because we're directly in line with it. But we'll see if we can do something else. All right, so there's our setup. We have our slings tied off. We have our angles. We have our pre-tension done. All right. And a V cut on a leaning branch is very similar to a lifting cut, but we're actually not going to do the top notch. We're actually just going to notch it straight in and let our operator slide it out. So here we just create the up part of our V on the bottom first. Gotta make some marks here so I can actually make it cut. And then we come up top. The piece jumped out a little bit. It wouldn't really move that much in real life. All right. And our sling got a little loose here. Hold on. Tie this sling back up. I must have hit it accidentally. I apologize. Oh, whoa. What's happening? It's all coming apart. Rails are coming off, Kale. I'm losing it.
That's all on your end.
Thanks. All right. Let me slide this back now. All right. So this kind of gets us a little bit more to the way we were oriented before I knocked it and set it loose. All right. So you can see with our V notch, I'm going to move the tree around here so everybody can see it better. Our V notch cut allows the piece to stay cut in there, and I did a little bit of a side V. So when you get it cut, it stays perfectly perpendicular. The branch structure doesn't move. And then our operator is able to just slide the piece out. All right, so that V cut allows it to stay trapped in there until our operator is ready to move it. And then the operator can slide the piece out. You've got the bottom that acts as a shelf, and the top acts as a nice little independent point there to keep it from moving. All right. Now we're on to our trunk section. So our trunk section here, we're going to use the secret handshake again. We're going to talk about that. And we're also going to talk about single sling attachments. So we're going to do this in 2 pieces, even though I know we probably don't really need to. All right. The first one we're going to do is a single sling attachment using our whoopee here. All right. We're just going to go around, get this nice and tight, hook that bad boy in there. So much easier. I'm going to put this underneath there. All right. So now we have our attachment. You can see here clearly in this, where our attachment point comes out is where we want to end our cut, not where we want to finish our cut. Because again, this piece is going to want to flip a little bit. It's going to want to lean. So if we started our cut with our chainsaw on this side, because our climber is resting here, and cut straight through, by the time they get here, the saw is going to be pinched. So we're going to start our cut on this side. So we're going to start over here. Maybe. There we go. You can tell I'm not a lefty. All right. So you can see right when I cut that piece free, how it leaned. That lean is what we're trying to avoid. So if you're the climber here and you've cut this piece straight through and you're resting right here, that piece is now coming at you. All right. This is why we use the secret handshake, or do a modify where we do a back cut with an angled side cut where we come in at an angle. And we'll look at that here in a second. We do the next setup on how to protect yourself as a climber. But you can see how this, no matter where we attach a sling at, it's always going to want to lean that direction. So you always start your cut opposite side of sling attachment. All right, take these off, put our spider legs back on here. Drop our ball down just a little bit. For those who care, I've talked so much that I've put my dog to sleep. So, yep, sound asleep. He's a good one. Yeah, really supports me. All right. So for the secret handshake again, we're going to take 2 of these slings and get 2 of these slings out of the way. So we don't need them. Kind of just daisy chain them up here a little bit. Hook them back on the crane ball. All right. So we're going to come down around this sling, attaching our running bowline here. All right. And this sling comes around and does the same running bowline on the opposite side. Wow, my hands just like not wanting to work on this small slings. Okay. So we've got our 2 running bowlines. And we want them tied so they're in opposing directions. So you can see how we have them tied here. They're opposing directions. Let me pull tension. All right. So now we've got them both tied on. All right. We can boom up to pull our pre-tension. And we're going to cut this piece off at the base, but we're going to cut it off in a manner where, say we had a fence here. All right, and this fence, we don't want the piece to hit. So we don't want anything to come this way. So we're actually going to finish, we're going to start our cut with a backside, like we're cutting a notch. All right. All right, so there's our backside cut. Then we're going to finish on the other side. I'm actually going to come around this side, make sure, yep, we're good. I'm looking because I got screws in this thing, and I don't want to hit the screws with the saw. All right, so as I get finished my cut, I can. Hold on. I'm going to bring the camera down so you guys can see what's going on here. All right. So what I have here on this side here is I have part of our V cut. All right. And when I move the piece away, you can see it there. What this does is as my crane operator lifts up, if for some reason they were to boom up, this piece is going to want to drift towards this fence we have. This is going to act as that stop to prevent it from hitting our fence. Okay. This also can be used in the tree to prevent the climber from getting hit. If I can get around here so you guys can see a little better. All right. So this just acts as a stop there. Still did a straight through cut, but I left this backside stop there to allow this piece to not want to swing past that point. So if I'm a climber, it gives me protection. It also gives protection for objects. And then at this point, my operator can very easily swing the piece out of the way. And then our tree is done. We can't cut the stump any lower due to screws being in the base of the stump. So that's where we're at with the end of the stump. I'm going to move our camera back here. Move it up a little bit. All right. So that was the wonderful takedown of the model tree with the model crane. Now it's time for questions and answers, I guess, and then kind of go over some other things. What would everybody else like to discuss or talk about in relation to cranes and tree work?
All right, awesome. I have a question here from Zach Smith about making a secret handshake with rigging thimbles to improve strength with a better bend radius. Do you think that would be something that you could do or would be necessary even?
I think you definitely could do it. If I was going to do it, I would use rigging rings and slide the rigging ring through as a secret handshake, and then do some form of termination knot on the maybe like a scaffold knot or maybe a double fisherman knot that cinches down on the ring and used it that way. That would be the only way I can think to do it. But I think it's a great idea. I think it's something probably, somebody could probably figure out how to tie pretty easily and pretty well, and it would work really well using rigging rings. The problem I would have is carrying the rigging rings with me for the tree. I'm a big fan of soft shackles or even the spring lock shackles that Crosby sells, where they're a single quarter turn shackle, very much like an impact block is. Those take a little bit more damage and also help the bend.
And then...
No, Victor, I'm not going to wood glue the tree back together. I need to get new friends. Thanks, Victor. Hey, Skillen.
Kind of
Glad
dog?
to see you made it. What kind of dog? He is an Australian cattle dog, and his name is Solo. And he's by far the best dog ever. So that's pretty much it. That's all I have. I know we're a little short on time. But again, if anybody has any questions, I'd love to help answer them. If you ever need to reach me, you can reach me, Travis Vickerson on Instagram. You can get me, Travis Vickerson, on YouTube. And, of course, as always, through treestuff.com webinars, you can find me there and contact me that way. Thank you for coming tonight. Thank you for coming into my kitchen. And hopefully everybody's staying home, washing their hands, and staying safe. And we'll get through the coronavirus together with many, many webinars, and look forward to telehandle next week.
All right. Thank you, everyone, for attending. Thank you, Travis, for taking your time out to show us how to do all this. I am going to be posting the link to the quiz to get your CEUs in the comments, as well as on the actual Tree Stuff Facebook page. So give me a few minutes to do that. Once you take that, we will submit all of that to the ISA, and they will update your training records, hopefully within a month or two. So thank you very much, and have a nice day, everyone.